syntax directed translation. Clearly, the syntax directed translation we are using as part of semantic analysis of the program. What is the difference between the syntax analysis and semantic analysis? Syntax analysis is identifying whether the given statement is in the given form or not. Okay, that means, for example, if you are identifying small expression a is equal to b plus c, it identifies whether it is having all the three required operands or not, required number of operators or not. Okay, that we are identifying even using the uh, various other intermediate codes, other intermediate codes. Okay, right. Using the intermediate code, we identified two forms. Okay. Uh, Similarly, now that quadruple code, triple codes we identified. Now we'll see once again how it will be evaluated using the syntax directed translation or using the syntax directed tree. Right. So the syntax directed translation we are using as part of the semantic analysis. Why we are using it? The parser uses a context-free grammar to validate the input string. That's the thing. What are the grammars we are using? We are using context-free grammar to validate the input string and produce output for the next phase of the compilation, and produces output for the next phases of compilation. The next phase may be a semantic analysis and then intermediate form. Okay, right. Our output could be either a parse tree or abstract syntax tree. Output could be a parse tree or abstract syntax tree. What is the difference between parse tree and the syntax directed tree? In the parse tree, it is covering each and every phase of translation rule. Okay, whereas abstract syntax tree, we are avoiding extra unnecessary information. Otherwise, simply we are avoiding all non-terminals. Okay, and we are keeping the terminals right away. Okay, so that we can execute that particular tree, a parse tree. That is the main difference between a parse tree and abstract syntax tree. So parse tree means it contains in the parse tree all the non-terminals also, whereas in the abstract syntax tree it doesn't contain that information, right? Okay, so now we'll add in addition with that particular information. Now we'll add semantic analysis. Okay, with the syntax analysis phase of the compiler. That adding the semantic analysis phase with the syntax analysis of the phase. Okay, we are using syntax directed translation. Okay, we are using syntax directed translation. So these syntax directed translations are nothing but augmented rules. We identified already what is the meaning of augmented grammar in addition with the parsers, in addition with the LR0 to LR1 grammar. We added augmented, okay, production. Here, in addition with the augmented production, we also augmenting this given grammar with some more semantic rules. Some more semantic rules. Be careful. Okay. The given grammar E is equal to E plus E or E is equal to E plus T. We added some augmented grammar. E derives E dash or E dash E derives E. Okay. In addition, that is for parsing operation to identify when to stop. Similarly, in the last classes, I showed you how to add semantic rules, how to add semantic rules in the given grammar to identify various arithmetic operations, okay, or assignment operations or other type of operations. Okay, right. So these augmented rules will be added to identify various semantics of the program or to analyze semantics of the program, simply called as semantic analysis, right? The syntax directed translation involves it parsing information. Parsing means to travel the tree from root to node, leaf nodes or leaf nodes to root nodes. Parsing is nothing but, okay, to travel the particular tree in order to evaluate various operations in the given grammar, right? So this syntax directed translation involves parsing information in general, bottom up, or even sometimes we use top down also, okay, in the form of attributes attached to the node. In the form of attributes attached to the node. The parsing of the tree either bottom up or top down in the particular tree in the form of attributes attached to the node. In the last classes, we identified already what is the meaning of these attributes. We identified S type of attributes, L type of attributes, or inherited attributes, or even I called R attributes. We know now what is the meaning of S attribute, I inherited attribute, or L attribute. In particularly, we required only those things, right? The semantic directed translation rules, whatever the rules we have for the part of semantic analysis we are using, generally lexical values of the nodes. Lexical values of the nodes are constants, are in particularly attributes associated to the non-terminals. Attributes associated to the non-terminals in their definition. Okay. So we are attaching all the rules, lexical values of the nodes or constants or the given semantic rules in the form of attributes. We are attaching to the non-terminals their definitions itself. So in order to validate each and every statement of the particular program, we are constructing the syntax of the particular statement, not only the syntax of the particular statement or expression, okay, we also adding some semantic rules to each and every statement in the form of grammar itself, in the form of a valid grammar itself, okay, right. So what is the general approach is, the general approach to the syntax directed translation in order to validate the statement, okay, identifying the syntax is different, validating the given statement is different, okay, be careful. So here the validation means whether we are identifying whether the operation successfully leading to the correct result or not, not whether it is in the correct form or not, okay, whether it is in the correct form or not, we identify using the various parsers whether the given string is acceptable or not. That means in the correct syntax or not. The validation means whether it is leading to the correct result or not. Okay. So the general approach to the syntax directed translation is to construct a parse tree or simply a syntax tree and compute the values of the attributes and computes the values of the attributes at the node of the tree by visiting them in some order and computing the values of attributes at the nodes of the tree by visiting them in some order. What it means, we know how to compute S attributes. S attributes are computed from right side of the production or directly from its children only. Inherited attributes, okay, it can contain the values from its parent as well as from the children also. L attributes, it can get values. The value of the L attribute can be computed either from the parent or from non-terminals which are on left hand side of the particular non-terminal. Okay, whatever the attribute we are computing, L attribute in what way we computed, okay, so we are getting the values for the L attribute either from the parent or from left side non-terminal of the production rule, right? So that is the attributes, okay. So in the syntax directed translation, what we are doing, simply we are constructing a parse tree or syntax tree, then we are computing the values of those attributes, okay, of the any nodes. Each and every node is representing a non-terminal, okay. We are computing the non-terminal in the tree by visiting the terminals or non-terminals in the tree in some order that we are going to demonstrate as in the form of syntax directed translation. Okay, right. The translation can be done during the parsing without building an explicit tree. The main thing is that the translation can be done during the parsing without building an explicit tree. Okay, that it is the demonstration of the remaining slides. So, for example, we are having a grammar E the productions for E T F. This entire thing is a single term. Okay, don't worry. Everything is looking as a non-terminal. Okay, right. So this is a grammar to syntactically validate. This given grammar by default is for syntactically validate an expression. Okay. In addition with we are using augmented grammar also. But basically this grammar is for validating the syntactic structure of the program. Okay. Or this is the grammar to syntactically validate the given expression. Syntactically validate the given expression. Okay. The expressions may include additions, multiplications, divisions, and other operations. Okay. Now, to carry out semantic analysis, to carry out the semantic analysis, 1 minute. Right. So, this particular grammar is syntactically validate an expression having the various operations like additions, multiplications, division, and so on. Now, to carry out the semantic analysis on the given grammar above and the above given grammar, will augment syntax directed translation rules. Okay, to carry out semantic analysis on the given grammar, which is meant for syntactically validate, will augment syntax directed translation rules to this particular grammar only. Okay, so when you are augmenting the some syntax directed translation rules to this grammar, in the form of to pass some information of the parse tree and check for the semantic analysis, we can validate whether the given statement is semantically also correct or wrong. Okay. So what we are doing, we are augmenting this given grammar with syntax directed rules to in order to pass some information of the parse tree and check for semantic errors. Okay. Right. So we are adding some more rules. So here, what is the thing here? These rules are already given rules to validate the E derives E plus T, E derives T, E derives T into F, E derives F. Okay, these are the rules to validate syntax of the program. These are the rules to validate syntax of the program. Okay, and we are adding some more rules. Okay, this production rule 1, production rule 2, production rule 3, production rule 4, production rule 5. All these are the rules. In what way you are going to execute this production E derives E plus T. Okay, what it is indicating in the form of the value of E is computed using value of E and value of T on the right hand side. Okay, so even in the tree, in order to differentiate the E on the parent side and E on the child side, or E on the left hand side, E on the right hand side, you may use suffixes, okay, or prefixes, okay, to the E, something, whatever the way we can utilize, right? So here the first rule is indicating the first production is nothing but an addition production. Second production is indicating an assignment operation. Third production is indicating a multiplication operation, fourth production and fifth production are once again indicating an assignment operation. Okay, right. So the thing is, this E plus P is indicating a production where the next possible symbol in the grammar or expression or statement, whereas the semantic rule, production rule number one is indicating that the next incoming symbol is nothing but an arithmetic addition, okay, not concatenation, okay. We are using both the plus maybe sometimes for a arithmetic addition as well as concatenation also. We studied it as operator overloading. We are studying this particular thing in our programming languages as operator overloading, but using these semantic rules, we are clearly mentioning what is the type of operation we are expecting for this particular grammar in the given expression statement. Okay, so we need not be, this rule need not be a single rule. For each and every production we can add as many production rules. Okay, we want we can add also the semantic rules, as many semantic rules as possible we can add to each and every production. Okay, to each and every production, right. So in this way, here we added only one rule, semantic rule to each and every production. Okay, so generally we are adding as many semantic rules as possible to each and every production, as many semantic rules as possible to each and every production, right. So these are we are using in the syntax directed translation, the syntax directed C, right. So for understanding the translation rules further, we take the first production in the STT, okay, augmented to E derives E plus P production rule. So what is the production rule we augmented? E value is equal to E value plus P value. Okay, we augmented this with the production rule E derives E plus P, right. The translation rule in consideration as value as attributes, the translation rule in consideration as value as attribute. The value, whatever we are adding, dot value is nothing but these dot values are nothing but attributes for both the non-terminals E and T. These E and T are on the right hand side of the translation rule. So the right hand side of the translation rule corresponding to the attribute values of the right side nodes of the production rule and vice versa. So generalizing syntax directed translations are augmented rules to a context-free grammar that associates set of attributes like dot value. If you want to, you can add some more rules, the dot color, dot any other thing. Okay, the size. Okay, or limitation. Okay, or in between. Various rules we are using even in the part of the DBMS also. Okay, or validation rules we are saying. All such can be added as attributes. Okay, so it can be a set of attributes to each node of the grammar. For every rule, we can indicate what could be the a correct value. Is there any lower limit or upper limit? Okay, or whether it should be greater than some value or less than some value. All this, the set of attributes to each node of the grammar, we are indicating as a syntax directed translation. So the set of attributes are nothing but the set of translation rules to each every production rule using attributes, constants, and lexical values. Attributes, constants, and the lexical value can be added to each and every production. So as part of the semantic analysis, we are adding augmented rules to each and every grammatical production. Okay, each and every production in the given grammar. Okay, that semantic rules can be in the form of set of attributes. Okay, and that set of attributes and also set of translation rules also. We can add like value. We can add as many attributes as you want. Similarly, we can add as many translation rules as you want. Okay, this the dot value and this the rule is only single one. Dot value is one attribute. Likewise, dot value you can add size, color, whatever it may be. We can use as many attributes as we can. Similarly, like this production rule, we can add as many production rules as we want. Translation rules. We call it as these are translation rules. This is the production rules. We can add as many translation rules as we want. Okay. We can add as many attributes as we want. We can add as many translation rules as we want. That is the thing. Okay. Right. So let's take a string to see how semantic analysis happens. We told the semantic analysis is nothing but the translation of a particular tree from top to bottom or bottom to top, left to right or right to left, various whatever the way we can do. Okay, right. So we take a small string. Let the particular string is equal to 2 plus 3 into 4. The general parse corresponding to the input string 2 plus 3 into 4 is looks like this one. Okay, this is the parse tree for a input string 2 plus 3 into 4. Okay, using the above grammar. Using the above grammar. Okay, we already identified this a couple of times. This parse tree, how we are building this parse tree for the given input string. Finally, what happens? All these non-terminals are replaced by the terminal. That means the terminal is at the leaf nodes, and the non-terminals are at the intermediate nodes. Root is the start symbol. Finally, whenever we are evaluating directly with the terminals or leaf nodes. Okay, that 2 into 3, 2 plus 3 into 4. Because based on the associativity or precedent rules, or based on the in particular the precedent rule, we are computing 3 into 4. Okay, then we are replacing that result with this particular t. Okay, similarly, this e is replaced by this 2. This 2 plus the result of t will be replacing the start symbol e. Finally, we are getting the result. And also, what is the one more indication here? This is showing we are getting the leaf intermediate nodes or root nodes, or we know the value of the parent node only after getting the child nodes. Okay, only after getting the child nodes. Until unless we are not getting the child node value, we can't get the parent node value. Until unless we don't know the value of the child nodes, we can't get the value of the parent node. Our value of the parent node is replaced by expression of the child node. Okay, that is the indication. Okay, that is the reason after removing all these intermediate nodes, we are directly getting the abstract syntax tree. Abstract syntax tree. Okay, so we are using abstract syntax tree for final validation. Right. So to evaluate the translation rules, we can employ depth first search traversal on the parse tree or breadth first search. Okay, in particularly in the syntax data translation, so we are using depth first search. Okay, why we are using the depth first search? Using the depth first search, we can know first of all what is the value of child node or leaf node, because the parent can't get the value until unless we are not getting the child node or leaf node. In order to get the child nodes or leaf nodes information first, we are employing depth first search. Right. So this is possible only because syntax directed translation rules does not impose any specific order or evaluation until child information. Okay. It is only possible for the syntax directed translation, does not impose any specific order or evaluation until child attributes are computed before parents of for the given grammar having all synthesized attributes. Synthesized attribute means itself we are computing value of a parent we are computing the value of a parent using this children. So we can't we impose any another thing because we need to first create the value of the children attributes. Then only we can compute the value of the parent attribute. Okay. So first of all, we need to compute all synthesized attributes information. All synthesized attributes information. That is the first thing. Okay. Otherwise, we would have to figure out the best suitable pair plan to transfer the policy. Okay, to transfer the policy and evaluate all the attributes in one or more traversals. Okay, or in one or more traversals. So, what is the translation criteria we need to use here? We need to compute first of all synthesized attributes. Synthesized attribute means getting the value of parent from its children only. Okay, then only we can compute the parent. So, first of all, we need to adopt that particular thing. Otherwise, we need to traverse the particular tree in more number of times and need to compute all synthesized attributes. Okay, right. So, for better understanding, we are using the bottom-up traversal in the left to right fashion. We are adopting the bottom-up parsing in left to right fashion. Okay, this is the one of the possible way to compute syntax directed translation. In the syntax directed translation, what we are adopting bottom up and left to right. And when you are traversing the tree from bottom up fashion, we are getting the children information or leaf nodes information before than computing the parent information. Before computing the parent information, we are getting the leaf node information. Before computing the parent information, we are getting the leaf node information or children information. Whenever we are adopting bottom of traversal, that too in left to right. Okay, that too in left to right. That means left to right generally we use breadth first search. Okay, this is bottom of traversal. We are adopting this book. Okay, right. So we identified a small expression previously. Okay, 2 plus 3 into 4. This is a given tree we identified earlier to get all this particular thing. This is the way how we are creating using this particular diagram. We are adopting breadth first and left to right. So in the breadth first traversal, here the thing is value of the E is computed using its immediate children E and T, E value and that plus then T value. Okay, right. If you want to get the synthesis attribute E's value, you need to identify from its children. What is the children for T? E. Children for this particular E is this T. Okay, the value or nothing but synthesis attribute of this T can be computed from its children F only. Okay, that is the reason we are created the abstract syntax tree because in the so many translations in the particular tree, all the nodes are having single children. All the nodes are having single children. All the single children traversals can be replaced by its parent. Okay, or directly from its children. The parent can be replaced by children. So F is replaced by 2. So that E is replaced by once again this 2. This E is replaced by this 2. Then we are calling it as abstract syntax tree. Then we are calling it as abstract syntax tree. Okay, even though if you are leaving in the abstract syntax tree, if you are considering even the parse tree, okay, in order to get E, we need to get values of or when you are considering it as a as attributed value, okay, this as attribute we are calculating from values of this E and T. This E is that means this E can be computed only after getting these two values. This E is computed from this T. This T is computed from this F. This F is computed from this 2. Okay. So after getting this 2, that means we are moving top to the bottommost position. That is the reason bottom parsing. Okay. Our depth first. Our depth first. We reach the bottommost position. Our depthmost position. Then we are using this value. this 2 replaces this F, this F is replacing this T, then it is replacing this E. Then we are getting the E value. Then once again, we are moving to the bottommost position, depthmost position. Then we are getting this E. Once this E, F value is replaced by 3, then the T is replacing this F value. Okay. Then we are moving to this multiplication. Then it is simply going for the other operand. Then we are going for the F. Then once again we are moving to the depthmost position. Then we are getting 4. This F is replaced by 4. Then finally, using this F value and this value, we are computing this T value. Now we are getting E and T values. Okay, that means this is a way of calculating the S attribute. Okay, synthesize the attribute. Be careful. It is not only the tree traversal. It is not only the tree traversal, but also calculating the S attribute or synthesized attribute. So finally, after getting these particular values, this E and T, we are calculating this E with the E value plus T value of this one, right? Only the be careful. If you are here in this particular case, here the left side also E, right side also E. Then we can substitute this particular thing with some subscript. Okay, some subscript. Okay, right. So the above diagram shows how we are identifying the semantic analysis using the given semantic rules. Using these given semantic rules, be careful. These are the semantic rules. Using these given semantic rules, we are adopting left first search and left to right, and using these semantic rules, we are replacing. Using the semantic rules, we are replacing. Okay, right. So after identifying this particular semantic rules, in the using the above diagram, whatever we are showing, we are analyzing the semantic analysis. If any value is deviating from the given semantic rules in calculating the F value or T value or E value, okay, it immediately rises a semantic error. It immediately rises a semantic error. Okay, these additions will be validated. These additions or multiplications will be validated against the given semantic rule. Is okay. If you are using here the semantic rules multiplication, it do the multiplication. If you are identifying it as a concatenation, it do simply concatenation. Be careful. It won't do the arithmetic operation. If the semantic rule we are attaching is a concatenation, instead of calculating this value, it simply concatenates. This T value will be concatenated with the multiplication sign, concatenated with the F value. It simply will do the concatenation, not multiplication operation. Be careful. So based on the value, what semantic rule, whatever we are producing, we are getting the result here. Okay, based on the semantic rule, we are getting the value here. Okay, so that is the reason I am telling you this is not only the traversal, but also at each and every stage, the synthesized attribute is calculating based on the semantic rules we are attaching. Based on the semantic rules we are attaching. Okay, right. That is the meaning of semantic analysis or syntax directed translation. Okay, right. The flow of information happens bottom up, and all the children attributes are computed before parents. All the children attributes are computed before parents as discussed above. Okay, as I showed you in the in this particular diagram, this translation. Okay, right. Now the thing is, the right hand production rules are sometimes annotated with the subscript 1 to distinguish that particular child with its parent. Okay, right side notes can be sometimes annotated. Annotation means adding the comment. Annotation is nothing but comment. Or we can add with a subscript. We can differentiate. Okay, left side the T value and right side T value. Okay, or left side E value or right side E value. Okay, this is called as a syntax directed translation. This particular diagram is called as syntax directed